Hello, hi. My name is Amandeep Singh. The topic of my project is fatigue analysis of a horseshoe. As we know, horseshoes are generally made of aluminium or copper, like in traditional ways. But that kind of horseshoes don't last longer. Earlier in old days, horses used to run in fields or it used to run in battlefields or on the muddy roads. So in that time the life of the horseshoe was big, but nowadays as there are concrete roads or we do sometimes horse riding on the built road, so the life of a horseshoe decreases a lot. So to make it better we need to increase the life, so we need to change the material. So introduction, by replacing the traditional with stainless steel horseshoes. These horseshoes can be used in sports like in polo, in horse racing, or chariot riding. On the we see the horses chariot in the downtown also. So that's the thing. This necessity to increase the life. Otherwise, it consumes lots of time and cost also to replace a shoe often. So I am doing a fatigue analysis of a horseshoe as horseshoe undergoes a cyclic loading. As it, we see that the normal speed of the horse is near about 50 to 60 kilometers per hour, or we can say 40 miles per hour. So that's why it goes a cyclic loading near about, we can say a normal horse run about 4 to 5 miles daily. So it's necessary for him to be trained 4 to 5 miles daily. So we can see that there are infinite times of cycle loading taking place on that horse. The next is the model details. The horse, yeah, first I want to clear that this is not the code sign, this is the horseshoe. The horseshoe design here is made of solid works, and the width of the horseshoe is 10 centimeters. And the depth of the shoe is near about 4 centimeters, and the corner of the horseshoes are fillet. So the fillet that is used here is near about 2 centimeters. So it has a holes here near about 8 holes. The pins are forced into these holes and they strike the foot of the horse, and they just remain fixed there unless they get broke or the horseshoe moved away. The other thing, the other thing here is these kind of horseshoes are not like the particular size. They are sometimes being forced from left or right to fit to the size of the horse. So next is the material properties. The material I have used here is stainless steel. So we know the properties of stainless steel. As the cyclist goes on increasing, the alternating stress, the cycles go on decreasing as alternating stress increases. So working on this principle only, I have made the fatigue analysis of this horseshoe. Meshing. Meshing is one of the most important work in the horseshoe or of fatigue analysis. The meshing size I have used is near about 1 mm fine. The number of nodes that came out are 1,63,783, and the number of elements that came out are 1,06,089. As a horseshoe is being hit by a horse on the ground, there will be acceleration also, and there will be pressure applied on it also. So the acceleration taken here according to the speed of the horse is near 80,000 mm per second square. So if a horse is near about a 60 mm, miles per hour, so it's normal speed. So the acceleration is average taken near about 80,000 mm square. As we know, the one side of the horseshoe is stick to the feet and the other hit the ground. So the compression is applied on one side only, not on the both sides. So on one face is like fixed and other is being like load applied. So this phase is shown as the compression only sport. In this phase, only compression is applied and the other phase is. So when we go around and we see that the alternating stress maximum seen here is near about 206.62 megapascal and minimum is 1.05.6 megapascal. So it shows the minimum and maximum. It's like minimum in the corner and maximum in the starting angle. Yeah, it shows the physical sport, the life. So as there is no that much weight on the stainless steel, so it will show deformation, but the life is near about 1 into 10 to the power 6 cycles. So we can say that near about it is like having infinite life, but it's not practically infinite because sometimes the pins they get detached or they get like broken away. So there is somewhat friction between the horseshoe and the feet. So that's why the horseshoe got broken away and while running it got removed. So we need to use the another one for that purpose. The pressure applied as the horseshoe hit the ground, there is pressure applied. That pressure is taken as 100 megapascal, as pressure is the force applied per unit area. So there will be pressures 100 megapascal, so it's only on the one side, not on the both sides. Safety factor. The safety factor seen here is near about 15 maximum and 0.4 minimum. So the maximum is on the base and the minimum is on the side. So this figure shows the total deformation. As we see, it will get deformed equally on the face, on the bottom face. So because the fixed support is on the back, and front face will see all the deformation. So we can see the edges. On the edges, it will be like different, and on that side, it's different. So this graph shows the fatigue sensitivity as the number of cycles increase and the static decrease number of cycles increase. So this is the all the project I have done for the fatigue analysis of horseshoe. Stainless steel can be a good as compared to aluminium and copper. Thank you.